Hello students, in this video I am going to discuss the questions from the subject steel structures which were asked in MES 2017. Question number 1. For compression members with double angle section, unequal angles are preferred to equal angles because. Now whenever the compression member is to be designed, we always prefer to go for the maximum load carrying capacity. So every designed section should carry the maximum value of load. The load carrying capacity of compression member depends upon the end conditions and the slenderness ratio. So on these two factors, that is end conditions and slenderness ratio, the load carrying capacity of compression member depends. Now slenderness ratio is given by effective length divided by minimum radius of gyration. Effective length is given by KL, so KL divided by R minimum. Now again one more thing which is to be noted is that as the slenderness ratio increases, so if slenderness ratio increases, design compressive stress decreases. So design compressive stress decreases as the slenderness ratio increases. As such, in order to stress the material to its maximum limit, means in order to have the maximum load carrying capacity, the slenderness ratio should be as small as possible. And to keep the slenderness ratio, that is this slenderness ratio, if we want to keep it as small as possible, R minimum should be maximum. And in case of double angle sections with unequal angles, the value of the minimum radius of gyration is maximum, and that is why the correct option is option 2. They lead to large value of minimum radius of gyration. Question number 2. Minimum pitch for riveted connections should not be less than, and the 4 options are given. Now in order to have the correct option for this question, we will have to refer to clause 10.2.2 of IS 800. Now according to this clause, the distance between center of fasteners shall not be less than 2.5 times the nominal diameter of the fastener. So it should not be, or the distance between the centers of the rivets, fasteners means rivets or bolts, the distance between center of fasteners shall not be less than 2.5 times the nominal diameter of the fastener, and that is why the correct option is option 4 in this case, 2.5 times the nominal diameter of the rivet. Next question, the effective slenderness ratio of a battened column lambda e is taken as 1.1 times the actual slenderness ratio of the column to account for, and the 4 options are given. Again, to have the correct option, we will have to refer IS 800 and the clause number 7.7.1.4. So this is the clause number. So as per this clause in IS 800, which states that the slenderness ratio of battened column shall be taken as 1.1 times the slenderness ratio to account for shear deformation effects. So it is clearly mentioned in this clause, the shear deformation. In order to account for shear deformation, the effective length or effective slenderness ratio should be taken as 1.1 times the actual slenderness ratio. So option 3 is the correct option. Next question, the maximum design force for a rivet in the following bracket connection if spacing between adjacent rivets is 150 mm is. Now the figure is shown. Now there are 5 number of rivets which are in this connection, which are shown over there, and the distance between two adjacent rivets is 150. It is also shown over there. A load of 450 kilonewton is acting on the bracket, and we can see that if we consider the group of rivets, the CG of the group of rivets will be exactly at the center of this central rivet, and the load is acting at a distance 160 mm from the CG of the group of rivets. It simply means that this load is eccentric for this group of rivets. Now the effect of this eccentric load is to produce two types of shear forces in each of the rivets in this group. First force is the direct shear force, which will be acting in vertically downward direction for each rivet, whereas the second type of shear force which will be induced in each of the rivet is the shear force due to bending moment produced by this force at the CG of this bolt or rivet group. In order to explain the two types of shear forces which are getting induced in each of the rivet, I have drawn this figure. I have shown all those 5 rivets over here. The distance between the adjacent rivets is 150 mm. So this distance is 150 mm. This vertical distance is also 150 mm. It is 150. This is also 150. Now on this side it is also 150. Now the total load which is applied on the bracket is 450 kilonewton. So the direct shear force, as the load is vertically downwards, each rivet will be subjected to a downward shear force, that is FD, which I have shown over here, and each of the rivet will be subjected to the same value of direct shear force, and which is given as FD is equal to 450 divided by number of rivets. Here the number of rivets is 5, so it is equal to 90 kilonewton. Now second type of shear force is the shear force which is getting induced in each of the rivet because of the moment. Now we can see that the load is acting somewhere over here on the right side of this group of rivets. As such, this force which is acting in downward direction on the right side of the group of the rivets is going to produce a clockwise moment about the CG of the group of rivets. As such, each rivet will be subjected to certain shear force due to this bending moment. Now this shear force, again, this shear force will be perpendicular to the radial distance of the rivet. So here, if I want to show the shear force due to the moment on this rivet, I will have to consider the radius. Radial distance means the distance of that rivet from the CG of the group of rivets. So this is the CG of the group of rivets. This is the rivet on which I want to get the force or shear force due to the bending moment. It will be acting like this because the moment is clockwise. So that is why this FM will be perpendicular to this radius and in the clockwise manner. Now if I want to get the shear force due to the bending moment on this rivet, I will have to consider this radius, and the force due to that bending moment will be perpendicular to this in clockwise manner, so it will be acting in downward direction. So we can see that for this rivet, FD is acting downwards, FM will be acting perpendicular to FD. Here FD is acting downwards, FM will also be acting in the same direction, whereas if I consider this rivet, FD is acting in downward direction as usual, whereas FM will be acting perpendicular to this radius in clockwise manner, so it will be directed in this direction. For this rivet, it will be acting perpendicular to this radius and in clockwise manner, so it will be acting in upward direction. So we can see that FD is acting in same direction for all of the rivets, but the direction of FM is different. It is clockwise, means the angle between these two is 90 degrees over here. Here both are acting in the same direction. Here FD and FM are acting perpendicular to one another, and in this case of rivet, FD and FM are oppositely directed. Always while going for the design of rivet, we will have to consider that rivet which is subjected to the maximum value of force. Now if we observe all these rivets, we can see that this rivet will be subjected to the maximum value of shear force, because here both of these shear forces, that is FD as well as FM, are going to add with one another, and we will find that this rivet is the worst affected rivet, and that is why the resultant force, that is the maximum force acting on the rivet, is FD plus FM, which is 90 plus this value. If we work out this value, it will work out to be 120 kilonewton. So 90 plus 120, that is equal to 210 kilonewton. So the rivet on the extreme right side, that is this rivet, is subjected to the maximum value of shear force, which is 210 kilonewton, whereas this rivet will be subjected to minimum value of shear force. And always we will have to while calculating the design force, we will have to consider the worst affected rivet, and this rivet is the worst affected, 210 kilonewton. So out of the 4 options, the correct option is option number 4, that is 212.5 kilonewton. Next question, the minimum thickness of a base plate TS in case of slab base can be calculated by the formula. Now in order to have the correct option in this case, we will have to refer IS 800 clause 7.4.3.1. So clause number 7.4.3.1 of IS 800, which states that the minimum thickness TS of rectangular slab bases supporting columns under axial compression shall be, the formula is given in IS code itself, TS is equal to root of 2.5 times W A square minus 0.3 times B square gamma MO divided by Fy. So the correct option is option number 3. Next question, the top chord of a roof truss is inclined at an angle of 20 degrees. No access is provided for maintenance. The live load to be considered for the design will be. Now the question is related with the live load, and as such we will have to refer to IS 875 part 2. Now table number 2, imposed loads on various types of roofs. Now here if we refer this table, then we find that if access is not provided except for maintenance, the uniformly distributed imposed load measured on plan area can be considered as 0.75 kilonewton per meter square for roof membrane sheets or purlins, less 0.02 kilonewton per meter square for every degree increase in slope over 10 degrees. So here I am just simplifying the things. In case of sloping roofs, in case access is not provided, the live load can be considered as 750 kilonewton per meter square, 750 newton per meter square up to 10 degrees. Thereafter we will have to deduct 20 newtons per meter square for every degree increase in slope over 10 degrees. And the formula for live load can be written like this. It is equal to 750, that is newtons per meter square, minus theta minus 10 into 20. So we will have to deduct 20 newtons per meter square for every degree over 10 degrees, or increase every degree increase over 10 degrees. So this is the formula, and it will give us 750 minus this angle is 20, 20 minus 10 into 20, so it becomes 750 minus 200, which is 550 newtons per meter square, and which means the value is 0.55 kilonewton per meter square. Option 4 is the correct option. Next question, if a structure is under fatigue stresses, then the welded joints as compared to riveted joints will fail. Now the option is clear. Option 2 is the correct option. The welded joints will fail later. So option 2 is the correct option. Next question, according to IS 800 2007, allowable vertical deflection for gantry girder with crane load electronically operated up to 50 tons is. Now in order to have the correct option for this question, we will have to go to table number 6 in IS 800, now which tells us about the deflection limits. It is the table number 6 in IS 800 2007. Now here it tells us about deflection limits. Now there are number of columns over, which are given over here. Now we will have to go to this column, crane load electric operation up to 50 tons. Now the member is gantry, the supporting it is supporting the crane, and the maximum deflection is span divided by 750. Whereas in case of crane load, electric operation over 50 tons, it is up to 50 tons, it is over 50 tons. Member is gantry, supporting crane, the span is maximum deflection is span divided by 1000. But here in the given question it is asked for electric operation up to 50 tons, and the correct option should be span divided by 750, and that is why the correct option is option 2, span divided by 750. Next question, the design bending strength of a laterally supported beam is given by MD is equal to beta B into ZP into Fy divided by gamma MO, where beta B, ZP, Fy and gamma MO have their usual meaning. Beta B for plastic and compact sections are given by. Now in order to have the correct answer for this question, we will have to go to clause number 8.2.1.2. so it is the clause number in IS 800. Now here in this clause the formula for design moment is given, MD is equal to beta B ZP Fy divided by gamma MO, and they are saying that where beta B is equal to 1 for plastic and compact sections, that is it is 1 for plastic section, it is 1 for compact sections, whereas for semi compact sections it is ZE upon ZP. So for this question the correct option is option number 4. For plastic as well as for compact section, the value of beta B is 1 each. So 1 1 is the answer, option number 4. Next question, the deep structural members subjected to transverse loads are called. Now deep structural members, we know that in case of beams, the beam is a structural member which is subjected to transverse loads. So deep structural member subjected to transverse loads is nothing but a plate girder, and that is why the correct option is option 3, plate girders.